Labas everyone, it's Vicky here, and in this tutorial we're going to explore Houdini's Vellum solver. I'm going to explain and show you how to use Vellum shelf tools to create cloth, wires, grains, balloons, soft bodies. There's quite a lot to cover, so let's get started. Vellum solver is a unified solver, which means that you can use one solver to handle many different types of objects and simulations. So you can use it to create things such as cloth, wires, soft bodies, balloons, grains, and you only use one solver to combine all of these types of simulations. Usually you would create multiple solvers in Houdini, but here you just use Vellum. According to side effects, the main advantage of this workflow is its controllability, stability, and ability to produce believable results quickly. So let's see if that's true. Before we start though, make sure your Houdini scene is ready for simulations. If you're not sure how to, I invite you to watch my other video on preparing scenes for simulations. Let's have a look at the shelf tools we're going to use. You can find them in the Vellum tab. So we have 6 Vellum simulations here, plus a surface collider which you can use for collisions. Vellum Cloth can be used for clothes, for fabric, sails, toys such as teddy bears, cushions, even bacon. Vellum Hair can be used for wires, fur, ropes, vines. Then we have two Vellum Softbodies, and these are quite similar. We'll discuss the differences later, but Vellum Strut Softbody can be used for jelly, marshmallows, pudding, whereas Tetrahedral Softbody can be used for things such as pizza dough or pancakes. Then we have Vellum Balloon, so obviously this one can be used for balloons or puffs, some types of fruits as well. And finally Vellum Grains, which can be used for sand, snow, sugar and other grains. Let's start from the left, so Vellum Cloth. To use it we need to create a geometry, and I'll rename this one to Grid Cloth. Let's dive inside, and in here you want to create a simple grid. Then we're going to drop down a transform node to move it up, make sure to display it. And you can either use the arrows when you have show handles selected, or just adjust the value. So I'll move it 3 units up. Okay, and finally we want to have null. It's not necessary, but it's a good practice. It will help you distinguish which parts of the network you created and which parts of the network Houdini created when you use the shelf tools. So let's display the null, and I'll just rename it to out cloth. Brilliant. Let's go back to the object level, select our grid cloth geometry and simply click on Vellum Cloth. After a while, you will see that it took you straight to the Autodop network, and in here we can click L and H to layout and home and zoom in to see what's happening here. If you cannot see your Autodop network, make sure you're in the object level, click H to home all. If you still cannot see it, just use the shelf tool again. Okay, let's dive inside Autodop network again. And in here we'll start with Vellum Object. Let's select it to see what we have in here. So Vellum Object simply takes our initial geometry and then creates a new object with attached data that is needed for the Vellum solver. And then you can see it's plugged into the Vellum solver, the first input, which says objects to solve. We also have the second input, which is for the forces. So if you hover over, you'll see the description. We'll add forces here later on, and the final input is for post-solve. Okay, let's see what we have linked here. Let's select the Vellum source and have a look at the options. So first of all, we have activation. So we can set activation to 1 or 0. Activation of 1 means it's switched on. We'll have it in our simulation. We'll have our Vellum source, the grid, in the simulation. Activation of 0 means that the Vellum source is switched off. So make sure it's switched to 1. And now we have 2 paths here. First of all, subpath, which is, as you can see, linked to our grid cloth, so the geometry we created, and to the geo something. We do not know what that is. The second thing is constraint subpath, which is linked again to the same geometry network and to the con something. Again, we do not know what that is. So to see and understand what these two things are, let's click on this icon to the right. It will jump to that node. If you click on it and nothing happens, make sure this option is switched off. So not like this, it must be like this, okay? Then when you click on it, it will take you to the node. All right, so we are in our grid cloth network. We have our 3 nodes, and then after the null, we have 3 more nodes. So here is the geo. So that was the first link. And then we have the con, which is constraints. That's our second link. However, these 2 things are just nulls. They do not do anything. They are just there so that it's easier to link certain outputs of the Vellum constraint node. So let's have a look at the Vellum constraints now. Select it. And here you can see that we have a lot of different options such as constraint type, stretch, drag, bend. So all of these allow us to determine how our cloth, in this case, is going to behave. However, these parameters do not affect the cloth itself. They create constraints, and if you zoom into your geometry, you will see what they are. Okay, so these are the white lines. These white lines are constraints that have been created for us automatically when we use the shelf tools. So the constraints are not subdivisions on our geometry. So if I select the out null, you can see that our grid is made of quads. However, on the constraints, we have triangles. So these white lines, if I switch on display points, are relationships between the points, so how the points are connected. And if I go to the geometry spreadsheet now, with the Vellum constraint node selected, you can see that we have our usual parameters here, such as position in X, Y, and Z axis, but we also have some other parameters such as drag normal, drag tangent, and mass and P scale and velocity in each axis. However, if I just select my null, we only have the position. So in short, these parameters are created so that we can control the behavior of the cloth. Okay, let's close the geometry spreadsheet. And I will also switch off the points. So whatever you adjust in Vellum constraints node, whatever settings you change in here, this will affect the constraints, so these white lines between the points. And also if we look at the outputs, we can see that we have the first output, Vellum geometry. So this is just our unchanged geometry, so the same one as we created here. Then the second output is constraint geometry. So these are the constraints. And then finally, we have the third output, which is collision geometry. So this is where you can plug in your collision geometry, and this will be the output for the collision. Okay, let's go back to the object level and dive inside Autodesk Network once more. So after Vellum Object and Vellum Cloth, we have Vellum Solver. So this is the brain of the simulation. It calculates what's happening. So in here we can adjust things such as time scale, sub-steps, so we can increase the quality of our simulation, and several other settings such as friction of the cloth, which is quite useful. The next node that we have in here is merge, and then gravity that controls our gravity, and we can adjust it using these 3 values of X, Y, and Z. And finally, we have the output. Okay, so this is it in our Autodesk network. Let's go back to the object level. And let's have a look if we have anything else here. So this is our original geometry. That's the Autodesk network. And we also have Cloth Vellum. Let's dive inside and see what that is. And again, let's go from the top. So first of all, we have import geometry. So this one simply takes our geometry from DOPS, so from the dynamic network, from our Autodesk network, and translates it so that we can use it in SOPs, so surface operators, surface networks, and then export it. Then we have 2 nodes that just help us with visualizations. We do not need to use them yet. Then we have import constraints. So this one imports our constraints, so the white lines, the relationships between points. Then we have a new node called Vellum I. In this node, you can export your simulation. And this one also has 3 inputs, so geometry, constraints, and collision. After Vellum I/O, we have Vellum Post-process, which is a very clever thing. So what it does is it takes information from our cache, so it's not simulating anymore, it's just loading from disk and using that information, and then it allows us to adjust our simulation, so do some final tweaks such as increase subdivisions, polish the collisions, or adjust the thickness of the cloth. We'll use that later on when we set up all of our simulations. All right, let's go back to the object level and let's play the scene. Let's see how it looks. Nothing exciting happens yet because we do not have any colliders. Let's go to the collisions tab and create a ground plane. Now we can see that the ground plane and our grid are the same color, so I'll just move this ground plane under the dop nodes. I will dive inside the geometry, so grid cloth, and before the null, I will just create a color node. So we want to apply a color to the grid so that we can distinguish it. Okay, let's go back to the object level and play the simulation again. So now you can see it falls to the ground again, not very exciting. So let's dive inside the grid cloth and we will pin this cloth in several places so that it doesn't fall, it just bends, okay? Let's find our cloth constraints, and in here we want to scroll down until we find pin to animation and pinpoints. Next to the pinpoint, let's click on the selection icon, and now we can select the points that we want to pin. So I'll select this one, then hold down Shift and select a few more, okay? Once you're done, click Enter. And I'll go back to the object level and press play now. So now you can see that something more interesting is happening now. So let's add another vellum geometry. Again, go back to the Vellum tab and we'll create a new geometry, this time for Vellum Hair. So I'll rename this one to Curves Hair. Let's dive inside, and in here I want to draw a curve. So just drop down, draw curve node. Okay, and now you can see this plane. This is where we can draw our curves. Make sure you have show handles selected, then you will see this small red circle which allows you to draw curves on this plane. So if I rotate, you can see it's just on this plane. If you want to change the plane's direction, you just need to go to projection and projection type from XY to YZ, for instance, or ZX. Okay, I'll just leave it as XY, and I'll just move this plane back so that it's on top of the cloth. And I created curves that I do not want to keep, so I'll just go to the stroke tab and you here click X on the first and second one, okay? And then I can go back to curve and draw new curves in here. Okay, brilliant. Then I will add a color node again. And finally null, so that we know where this part ends. And I'll rename this one to Out Hair. Let's go back to the object level. I will select the curves hair and then click on Vellum Hair shelf tool. And again, it takes us to AutoDop network. We have several more nodes created here. So let's click on L and H to layout and home. And you can see we have our ground plane. Okay, we have the vellum object, grid cloth vellum, and curves hair vellum. So you can see that we do not have another solver. It's all linked to one solver, and we also have only one vellum object. The only thing that has been added is the curves hair vellum, so the vellum source. And this vellum source is exactly the same as the other one. So the only thing it does is it links the subpath and the constraint subpath. So let's go back to the object level now. Let's see if something changed there. So no, I'll just click H to home all. No, we do not have any new nodes. We still have only one cloth vellum. We do not have any hair vellum group created here. Let's dive inside the curves hair to see if anything changed here. Okay, so again, you can see the same thing. We have our curve, then we have hair constraints, and then we have two outputs, so geometry and constraints. In hair constraints, we will see similar options to what we saw in the cloth constraints. Let's play the simulation. Let's see how it looks. Okay, I need to go back to the object level to see it better. Okay, you can see it's too far away, so I need to move these curves closer to the cloth. So let's dive inside the curves. And now I can, after draw curve, I can drop down a transform node. And I'll just move them a bit closer. Okay, and let me play the simulation again. All right, so you can see straight away that the curves are interacting with the cloth. So we have one solver, they're all linked to one solver, and this is why they are interacting so well. So what we want to do here is also use pinpoints to pin these curves here at the top so that they do not fall. Let's dive inside curves hair and then find our hair constraints, and we'll use the same thing as we did for the cloth. So let's scroll down and find pin to animation, then pinpoints, take the selection, and it will just select these points at the top. Once you're done, just click enter to confirm, go back to the object level and play the simulation again. Brilliant! So you can see that the cloth simulation and the hair simulations are very similar, and this is because they are using the same solver. Let's have a look at Vellum Softbodies now. So we'll create another geometry, and this one is going to be for the Strut Softbody. Let's dive inside, and in here we want to use, for example, one of the test geometry, for example, pig head. Okay, I'll use a transform node to move it up. And I'll just move it to the side, so we'll have several pig heads here just so that we can compare them. So make sure you leave a bit of space on the right. Okay, and finally null, which I'll rename to out strut Softbody. Okay, make sure the null is displayed, go back to the object level, and now we'll select this geometry, click on Vellum Strut Softbody, and again it takes us to the auto network L and H. And again, the only new thing that has changed is this new Vellum source. And this Vellum source is exactly the same as the other two. Let's go to the object level and just play our simulation. Okay, so as you can see, Vellum Softbody can change its shape. It can bend, we can squeeze it, however it comes back to its original shape. Okay, let's dive inside this geometry, see what we have in here. So now we have two new nodes. So after our out strut Softbody node, null, we have Vellum constraints. If I just zoom in, you will see that we have the same type of constraints as we had for the cloth simulation. So this tells us that the outer side of this geometry is actually a cloth. And it's also named stretch cloth. So this one allows us to control how the shell of this geometry is behaving. And then we have strut constraints. To see this one, let's go to the wireframe. And now you can see that this one creates constraints inside our geometry, and this is what makes the geometry not fall apart or squeeze too much. And again, you can adjust several settings over here for the stretch, for example. Brilliant! And the same as for the other two, we also have three outputs, so the geometry, the unchanged geometry, the constraints, and the collisions. Let's go back to the object level now. And let's create another geometry for the other Softbody. I'll rename this one to Tetrahedral Softbody. Okay, let's dive inside, and again I want to create a pig head so that I can compare the two. Okay, let's drop down a transform node. And finally the null. And I'll rename this one to out Tetrahedral Softbody. Make sure the null is displayed, go back to the object level. Now we'll select our Tetrahedral Softbody and click on Vellum Tetrahedral. Again, L and H, and you can see the same thing, surprise, surprise. We only have one new node in our Autodop network, which is the Vellum source. Let's go back to the object level and let's dive inside the Tetrahedral Softbody. But in here you can see that much more is happening. So we have our three nodes and a bunch of other nodes. So what do they do? Well, the first one is polyreduce. Let me zoom in. I'll go back to the smooth wire shaded. And let's just remember where is the display flag, so on point deform. and I will display the point polyreduce. You can see that polyreduce reduces the number of detail. So if I want to increase the detail, I can increase the number to keep. If I want to reduce the detail, I just reduce that number. Let's just undo that, Control Z. Then remesh, which simply remeshes the geometry. Then we have solid conform. Then we have tetrahedral constraints, so the relationship between the points, the bonds between the points. We have our two outputs, so geometry and constraints. And we have several other nodes which we will not discuss today. So let's go back to the object level. I'll just zoom out, and now you can see that we have our GeoTetra Softbody, but everything else is gone. So if you want to see the other objects as well, you need to click on Cloth Vellum. Okay, we need to display it, and now we can play the simulation. Okay, so now you can see the difference. We have the Strut Softbody, which is trying to preserve its shape, and we have Vellum Tetra Softbody, which is just more fluid-like. Let me just hide this geometry, so we'll only see the low-res version of the pickhead, and I'll add another geometry in here for the balloon. So this will be Geo Balloon. Let's dive inside. And in here, I want to again use one of the test geometries, for example, rubber toy. Okay, and again, transform node. And I'll just move it up. I'll place it in front of the others and just increase its size. Okay, and then finally null, out balloon. Brilliant, let's go back to the object level, select our out balloon and click on the Vellum Balloon. Again, the same thing happens in the Autodop network. Let's go back to the object level and play. So now you probably see that the simulation is very slow. So what we can do is decrease the number of subdivisions on these geometries. So let's dive inside the Strut Softbody. I will select our test geometry and change the difficulty mode to easy. I'll do the same for the other pickhead. And I'll also go inside the balloon, and you can see that we cannot change the difficulty here, so I will just use polyreduce. Let's zoom in, and I want to lower the percent to keep. Let's go back to the object level and play the simulation again. So you can see that the simulation is a bit faster now, and you can also see the difference between our three soft bodies. So even though they all look very squishy, the main difference is how they preserve the volume. Let's have a look at the side effects guide again. The first type is Vellum Balloon. When squeezed, it makes the squeezed part flat, but bulges out distant areas. It behaves as if there was a fluid, such as air or water, traveling in its interior. It uses two constraints similar to the Strut Softbody, cloth for the outer shell and pressure constraint to keep the cloth from collapsing. Then there are two softbodies, Tetrahedral and Strut. Tetrahedral softbody processes the geometry by simplifying it, remeshing and turning to tetrahedrons. It uses the tetrahedral constraints as opposed to the Strut softbody, which consists of two types of constraints, cloth for the outer shell and handles which preserve the geometry volume almost like toothpicks or springs holding the geometry together. Okay, so that's enough theory. Let's go back to Houdini. Okay, let's dive inside our Geo Balloon and let's see if anything changed in here. So after the null we have stretch cloth constraints. So this is the same node as we had for the Strut Softbody. And then we have pressure constraints, which we can see better if we change to the wireframe. So these are the constraints that make the balloon keep its shape and deform as well. So we have one final simulation type left. Let's create another geometry and I'll rename this one to Geometry Grains. Let's dive inside, and in here we can, for example, create a platonic solid. Let me zoom out and I'll change to smooth wire shaded again. And I'll change the solid type on the platonic solid to Utah teapot, and I'll just move it up. So I'll use the transform node and move it about 5 units up. Okay, more. And I'll also increase the size. So I don't want it to intersect, I just want it to be above our objects, like so. Okay, and finally null, you can also add color node to see how it affects our grains. So I'll just change that color to green, for example, and then display the null and rename it to out grains. Okay, let's go back to the object level, select the grains, click on Vellum Grains. Again, nothing major changes in Autodop network, so let's go back to the object level and see what we have in here. So now the Utah teapot changed, and now we have a lot of spheres inside it. And when we play our simulation, you will see that these grains, these spheres, interact with everything else in the scene. However, they do not take the color of the color node that we use inside the geometry. So if you want to apply a color to the grains, you'll need to do it later on in the process. Let's go inside the GeoGrains and let's have a look at the node we have. So Vellum constraints, this time we do not have many options here. We only have grain size and mass. So grain size is just the size of the grains. The higher the number, the bigger the grains will be, but also we'll have less grains in the geometry. So if I increase this to 0.5 and go back to the object level, you can see we do not have that many grains. If I change that to 0.05, now we can see that we have quite a lot of detail and a lot of grains in here. So obviously the higher the number, so the bigger the grains, we'll have less grains, but also faster simulation. And the other way around. Let's have a look at one more thing here before we add any colliders. The only force we are using at the moment is the gravity. So to make it more realistic and fun, let's go inside the Autodop network and we're going to add a wind force. So as I already mentioned before, we can add forces in the Vellum solver, so we can plug in forces to the second input of the Vellum solver. So let's go to the tab menu and then pops, and here you will see a lot of different forces such as pop wind or pop drag. So let's drop down the pop wind node and then plug it into the second input of the Vellum solver. Now in the pop wind you can see a lot of different options. I discussed these in my other tutorial, so I invite you to watch that one if you want to learn more about pop wind. And if we play the simulation now, you will see that the wind will affect everything in the scene, and this is because all of our objects use the same solver, so Vellum solver. They are all plugged into the Vellum solver, so whatever force we add here will affect all of them. And this is why the manual approach, which I will discuss in another video, is probably better if you want to differentiate forces for each object. So let's just increase wind velocity. Let's go back to the object level and play it. Alright, so because it slows down our simulation, I will just go back to the Autodop network and just delete this pop wind node. Once we have all of these simulations, let's have a look at the final thing called Surface Collider. If you go back to the Collisions tab, you can see that we have it over here as well. So now we have three collider shelf tools. First of all, static object, which is used for not moving objects. Then we have deforming object, which is used for animated and deforming objects, which means the ones you keyframed parameters on. And these two shelf tools use volumes, so they use voxels or VDB representation of your geometry, whereas Surface Collider only detects the surface and works with the surface of the geometry you're using. It's also used for animated and deforming objects, so it's very similar to the deforming object shelf tool. However, this one is for the volumes, so VDBs, voxels. This one is only for the surface, the shell. So let's create another geometry. I'll rename this one to Geo Collider. Let's dive inside, and in here I'll just create a simple box. And I'll change the primitive type to polygon mesh, create a transform node so that I can resize it and move it. So I want to place it above everything else, and then I will animate it so that it squeezes everything that we have in the scene. Okay, so I will click on this brain icon for a second to disable the simulation. And then move to frame 25 or 35, let's move to the frame 35, and I will Alt-click on the Y translate value, Then move forward a few frames. Move this box down. And hold down Alt and click on the value again to set the keyframe. Let's play it and see. Now I'll drop down null. Of course, as always, display it and rename it to Out Collider. Let's go back to the object level. I will switch on simulation now, and we need to add our collider to the simulation. So let's just select it and click on Surface Collider. And let's just double check if it worked. So go inside Auto.Network. Here we go. That's our Geo Collider. All right, so now I can play it. Brilliant, so everything is working now. It's a very strange simulation, but what we notice is that the quality of our geometries is quite low, and this is because we reduced it. We wanted the simulation to be faster, so we reduced it. And there is a way to fix that. So let's dive inside the Cloth Vellum. And in here I already mentioned that we have Vellum IO. So what I want to do is now cache my simulation to the disk. So make sure you're using the bgeo.sc extension as well as $F, which means that you're saving more than one frame. So you will be saving this frame range. So what I will just do is click Save to Disk, and once it's saved, I'll be back. Once it's done, we can simply click Load from Disk. And now our simulation will not be resimulating. It will just be loading the files from the disk, so we can play it more or less in the real time. And what we can now do is also post-process our simulation. So as I mentioned at the beginning of the video, post-processing allows us to, for example, subdivide the geometries. So we can subdivide the cloth, we can subdivide the balloon and the Softbodies. However, there are objects that cannot be subdivided, such as the wires or the grains. So let's see what happens when we use the subdivision. So let's change the subdivision type to loop or Catmull-Clark. So these are our two options here. And if I increase the number, okay, you can see that these geometries are much smoother. And when I play the simulation, when I play the cache, sorry, we'll also get a nicer outcome. However, the hair is gone. So it would be good to split these two things here. So what we'll do is just make some space in between Vellum IO and Vellum Post-process. And I'll create a null. Okay, just place it here. And I'll rename this one to Geo, so that you can see that the third output and the first input and the first output are for your geometries. The second ones are for the constraints, and the third ones for collisions. And now I will just duplicate this null by holding down Alt and dragging it to the left. And this one will be Geo non-process. And the second one, process. And now I need to divide our simulations. So what I will use here is simply blast node. You can use either delete or blast. Okay, by default it blasts everything. So I just need to click on the selection and select what I want to keep and what I want to delete. I'll just select our geometries without the hair and without the grains. Okay, once it's selected, click enter. And we want to delete non-selected. Now we'll duplicate this blast node again by holding down Alt and dragging to the left. And I want to place it before non-process. And now I will switch off delete non-selected. So on the first blast node, I have the grains and the wires. On the other one, I have everything for smoothing. So this blast node goes into Geo process and then inside the post-process node. So in here I can make some changes. I can increase the number of subdivisions. I can even increase the thickness. So if I switch this on and zoom into our cloth, what you will see is that it added thickness to that cloth. Okay, and now I need to merge these two. So I need to merge our cloth and Softbodies and the hair and grains. So what I will do is just simply create a merge node and connect Geo non-process and Vellum Post-process node. So let's play it and see how it looks now. And that's it in this video. I hope you enjoyed this introduction to Vellum Solver, and I'll see you in the next one.